Okay, here is a demo of the system. This is student S1. His first name is S1 and so is his second name. He's working in Chrome, and here's the course. Now the theme has been changed to be orange to easily distinguish from student S2, because student S2 bizarrely has a very similar name. His first name is S2, his second name is S2, but they're using different browsers. S2 is working in Firefox, S1 is working in Chrome, and he has his orange theme. So let's click on this. If you go to S1, you can see that S1 gets this set of exercises and S2 gets a similar set of exercises. But when S1 clicks on his insertion sort problem, he's given the specification of the problem. This is what it looks like, and the problem actually depends. Each student who gets this problem will also get a list of numbers. This numbers has been generated by a random number sequence generator, so that it's based on the student ID. The problem structure is the same, in much the same way as, say, you've got a chessboard. A chessboard will have a particular structure, but the sequence of pieces will sort of define the chess problem. And this is the same way. The sequence of numbers defines a specific problem. And if you go to student S2 and look at his problem, you will see that he has a different set of numbers which are defined by that student's ID number. So when S1 goes to solve this problem, now he's actually already solved this in previous exercises, but here I have recorded S1's solution. So this is the solution for S1. So I will copy that because it would just take too long to actually solve it there in front of you. So I'll save that solution and then I submit it, and you should see it gets marked almost immediately and he gets 100%. Now let's say student S2 comes along and he decides to create his solution, and let's say he just decides to use the solution for S1. Well, it's a different problem, so you wouldn't expect this to work, and sure enough you see his grade is 0. Okay, so that shows it. So he could go along and he could get his solution, which I have here, and it is this. Now in this case, in neither of these solutions do I know them. I wrote a program to generate the problem, and the program also will generate the solution. So this is not like a question bank or anything. Each one of these are generated dynamically. If there were 1,000 students, they'd all get different exercises which would all have different solutions. Well, there's a small chance they might overlap, but so that's that exercise. Now a lot of the exercises were along those lines. They were sort of text based, but I want to show you a few different ones. So let's say I've got student 1 and he goes to a different exercise. Let's say Dijkstra's shortest path algorithm. Now in this case I will just go full screen here for a minute, so you can see that this is the randomized part. This is in a way the sequence of numbers, and this is the program. So let's go back here and have a quick look and see what happens when S2 looks at this at his shortest path problem. You'll see that he actually gets a completely different now these are called graphs. You can sort of imagine them as like a set of cities with different distances between each city, and you have to find the shortest path between them. This would be similar to how Google Maps would find the shortest path between a distance. So that's what the students have to do, except they have to do it using a particular known algorithm. Okay, so let's say this guy comes along and he wants to solve it. Now again, I could do this. I'll just go full screen there. I'll click on the description. Oops. Click on the description, and if so, the student can watch this and they can submit their solution. And the basic idea is you submit a list of numbers corresponding to the solution. So the distance from A to every other node. So the distance from A to A will be 0 in length. The distance from A to B, well, it looks like it's 21, but in fact there's a shorter route here. If you go via G, it's 1 to G, and it's 8 then to B, which gives you 9, and so that's where you get the 9. And you can fill in all of those. And in fact there's a slight error in this because the 1 has been left out. So if I submit that solution, it tells me my solution should contain 7 distances, whereas this only contains 6. So let's say I add in the 1 again, save that and submit it. You see it gets full marks. Okay, so I got 100 out of 100 because I'm so good. If I go to let's copy that whole solution and again go to student 2. If I submit my solution, obviously it's not going to work, so I save that, and sure enough, I'm not very good. I only get 0. If I remove that solution and give them this solution, this is, I think, the correct solution for this guy, so he gets full marks. So you see, each student has to solve these separately. Now there's one, I just quickly talk about the problem. So if I go back here and have a look at the description, oops, maybe I have to click there. Oh, what's happened? I don't understand. Sometimes it. Okay, so there's the description. So you see this graph here. I can right click on that and go to view the image. If I view that image, you can see it actually looks like an actual image file, but in fact this was generated by a computer program. If I change this number to anything, let's say 0, it generates a completely new graph. I can specify the number of nodes with the 7. I could make that maybe down to 5. So let's say I only want 5 nodes. So it gives me 5 of these nodes. This is the probability that they will be connected. So if I go up to 0.9, I think there are far more. There's still only 5 nodes, but now there's lots of connections between them. And again, I can change that number. I could go up to 800, and it generates a completely new graph. So there's many solutions. Now it's stored internally as a representation. It's just the student only sees the image. But with that representation, I can also generate the solution, which is being used to compare the mark. Okay, so that's an example of a very useful exercise. It's quite easy for the students to do. They can discuss with each other, and it will be marked automatically. So that's one problem. I want to show you now another problem. I'll just go back here. So this is student S2, and I want to go back to student S1 because I want to have a look at another one. Now this is called sorting detective. So if actually I'll do that with this guy, sorting detective. Now this is there's a computer conference in America which has this it's computer education conference, which has this a stream called Nifty Assignments for interesting assignments, and one of them is this sorting detective exercise. Now it's from a long time ago, but it was always one that fascinated me. I really liked the idea, and it was a backwards way of looking at problems, which often helps students to get a good insight. So there was a problem with it, which was there was only one solution, which meant it was, if students told somebody else a solution, you have a problem. So basically what I did was I modified it so that it could have many solutions. So let's say I go down here. You'll see that each student gets a different seed. Now if I change to /downloads, I can then run this program, and I give it my seed, which will be 182, and I can run that program, and then it gives me this. And basically I can use this program to investigate these various secret algorithms. So I click them and it gives me some information here, and I can use that to work out what the various algorithms are. Oops, I knew there's something wrong here. Well, no, it might be very interesting. But so I can use this to find them, and then I enter the solution here. After performing this experiment, I enter the solution. I've cheated because this takes a little bit of time, maybe 15 minutes of experimenting, and then you submit the actual correct solution is this one here. So I'll just copy this and put it in here, and just need to hide this one here or do that. So I click that, and it gives me fewer marks because there's a penalty for repeated submissions. Okay, so that's how that works. So this shows you there can be quite a variety of style of question, and they can still be automatically marked, etc. Okay, thank you. That's a demo of the system.